Hey guys, it's Miss Johnson, and I'm here to bring you our notes for Unit 3, Notes 1, which is on basic probability. We're kicking off Unit 3 here. So far in Unit 1 and Unit 2, we've been talking about the statistics side of probability and statistics. We talked about a bunch of different graphical displays. We talked about measures of central tendency. We talked about measures of variance and spread, percentiles. All of those things were the statistics part of probability and statistics. Now in Unit 3, we're going to kick off the probability portion of probability and statistics. So Unit 3 is kind of just our introduction to regular probability, basic probability, and then Units 4, 5, 6, and 7 get into all sorts of other kinds of probabilities depending on what kind of data set that you're looking at. So this is our basic probability unit, and today we're kicking it off with stuff that you have definitely done before, you've definitely seen before. This is just basic, good old probability that calculates your odds of something happening. So let's just talk about what probability is. Probability is, I can get my arrow here, there it is. Probability is a measure of or estimation of how likely it is that something will happen. How likely is it that something will happen? It's a value between 0 and 1. So you're going to have a decimal or a fraction between 0 and 1, and you're not going to have any negatives. There's no such thing as a negative probability, okay? So no negatives. Okay, and it's a fraction or decimal. Can't be bigger than 1. You can't have over 100% chance if you think of it that way. You can't have something that's above 100. The higher the value, the more likely then the event. So again, you can kind of think of that as a percentage. If the value gets higher, that means that it's more likely to occur. Here's some notation for you. We're going to use this P of A being whatever the event is. So you'll see whatever it is that we're looking at or doing is going to go inside those parentheses. And then we have a basic probability calculation. So our probability calculation is the number of successes divided by the total possible outcomes. Some people like to call that the part to whole. That's another way of thinking of it. Okay, so part to whole. Number of successes to total possible outcomes. If you guys can think back to intermediate algebra when you were freshmen, you definitely worked with, or some of you in 8th grade, you definitely did this fraction and worked with probability when you were in intermediate algebra. Even in algebra 2, there's a little bit of probability that they do in algebra 2 as well. So all stuff you've seen before today. All right, so let's just jump into some examples here. It says in example 1, calculate the following probabilities. You have a bag with 3 red marbles, 2 green marbles, and 5 blue marbles. First, you're going to find the probability of a blue. So when we're setting up the probability of a blue marble, what we need to look for is, well, if I used a color you could see. So for the probability of blue, we need the number of blue out of the number total. So if I look up the n, remember how I told you you were going to find n every single day this trimester? Well, there it is. We still need our n. Our n here is 5 plus 3 plus 2, which is 10. That's our total number of marbles. And the blue ones are 5. So 5 out of 10, or in other words, 1/2. Or in other words, 0.5. So now I will tell you that while this is the correct fraction, this is how you'll see it, or this. You will see either a reduced fraction or a decimal, if this were like a multiple choice test of some kind. You will not see 5/10 written like that. Probability of green. Probability of green, I already know my n because I found it. So my green is going to be the number of green divided by the total. Number of green is 2, and the number total is 10 still, which is the same thing as 1/5, or in other words, 0.2. So again, you can give me the decimal, or you can give me the reduced fraction. I think there's a couple more here, or maybe just one. Probability of red or green. If it's a probability of red or green, this or tells you that you're going to add those two successes together. What that means is you'd be happy if you get a red, and you'd be happy if you get a green. So they're both considered successes. Red is a success and the green is a success. If they're both successes, then I need to add them together. So I have the probability, or I have the number of red plus green over the number total. In this case, the red and the green, I think it's 3 and 2, right? Yeah. 3 plus 2 over 10, which is still our total. That's 5 over 10, or in other words, 1/2 again, or 0.5 as it will be most often. As we get deeper into the probability stuff, you're going to see that it's going to be a lot easier to write your things as decimals. This early on in the unit, your fractions are still pretty simple, so it's not hard to reduce them. But when we get into some bigger fractions and we start multiplying things and raising things to powers and things like that, your fractions get a lot bigger, and then you're going to be making your probability into a decimal instead of reducing it. Okay. Calculate the following probabilities given a standard number cube, or in other words, a die, a standard 6-sided die. So what is the probability on a 6-sided die that you roll a 3? That's what they're asking in part A. So a die, if you remember, has 6 options, and it's 1 through 6 each one time. So each side of the die has a different number, 1 through 6. So we need to set up our probability fraction here. You need to think about how many times does the number 3 appear on a die. 3 appears on a die 1 time out of 6 total options, or in other words, 1 out of 6 is 0.16 repeating. So let's talk about the rounding for a second, because now we have a repeating decimal. So what happens with 1 out of 6 is we get 0.1666666, and it goes on and on and on. In probability, you're going to round to the 3rd place. That's what our probability decimals do. You round to the 3rd place. So that means you need to take the 4th one and use it to round the 3rd one. So I would call this 0.167. Now, again, 1/6 is a simple fraction. You could certainly leave it this way. 1/6 can't be reduced, and that's perfectly fine. But just so you know, as you get further along in these decimals or the fractions get bigger, the decimal gets round to the 3rd place. All right, let's talk about B. Probability of a number being less than 5. Notice that that's not including 5, that's just strictly less than 5. So the numbers that are less than 5 are 1, 2, 3, and 4. So that means there are 4 of them. So that gives me 4 out of 6, or in other words, 2/3. And again, this is a repeating decimal. 2/3 is 0.6 repeating. And it goes on and on and on. So I would use that 4th 6th to round to the 3rd 6th, and I'd call that 0.667. Okay. Let's talk about a multiple of 2. So if I think about a multiple of 2, that's a number that you multiply 2 by, and it gives that result. So you can also think of that as counting by 2s. 2, 4, 6, 8, 10, 12, and so on and so on. On a number cube, the multiples of 2 are 2, 4, and 6, because then 6 is the largest number on the number cube, and it doesn't go any higher from there. So there are 3 of them. That gives me 3 out of 6, or in other words, 1/2, or in other words, 0.5. I'm just writing each of those answers each time. You don't have to give me both answers. If you give me either the reduced fraction or the decimal, that's fine. You do not need to give me both. Okay, as long as you go from here to there or here to there, that'll be just probability of a number being greater than 6. So think on a number cube, how many numbers are greater than 6? Well, that answer is 0. So we could really set up our probability fraction here if we wanted to, but our probability is going to be 0. Okay, some people call that the null set, where they cross through the 0. Null just is another way of saying nothing. there's nothing in that set of solutions because there are no solutions that are greater than 6 on a number cube. All right, so now let's talk about cards, decks of cards. I put a standard deck of cards picture here for you. Some of you maybe are not as familiar with a deck of cards as others. Depends on whether you played cards as growing up in your house. I also have a standard deck of cards available in Schoology, just like a PDF of basically this thing that you're looking at right now. But the makeup of a standard deck of cards, there's 52 cards total. There's 4 suits. You can see that the different suits are the different pictures that are on the card. So you've got clubs, hearts, spades, and diamonds. And then within each suit, there's 13 different cards. Ace all the way up to king. The numbered cards are from 2 to 10. The face cards are the jack and the queen and the king, literally because they have faces on them. Ace is kind of an anomaly because it's not a number or a face, so it's its own type of card. And then, yeah, half the deck is black, half the deck is red. So there's a whole bunch of specifics about a deck of cards that you will be asked about throughout the rest of this trimester. And if you're not familiar with a deck of cards, that's okay. Like I said, there's a little sheet that is in Schoology, and you can also have it, get it on paper, and that will help you with your decks of cards if you're not familiar with them. Okay, so let's talk about the probability of getting a 4. If I look at my deck of cards, here are my 4s right here. There's 1, 2, 3, 4 of them, as there are every other type of card. So there are 4 4s out of 52 total, which if we reduce that, that's the same thing as saying there's 1 4 out of each suit of 13. So 1 out of 13 looks like that, and I'm just going to grab my calculator here and see what that would be as a decimal. 0.077 if I round that. My decimal looks like this, 0.07692, and it goes on. So if I round that to the 6, I need to look at the 9, which rounds it up. So this is 0.077 for 1 out of 13. Sorry, my decimal didn't get in the box there. Face card, probability of getting a face card. Face cards, again, are the ones that have faces on them. So if I look in my suits, or if I look in my whole deck, there's 3 in each suit. 1, 2, 3, so then 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 face cards out of 52 total cards. That's the same thing as 3 out of 13. And 3 out of 13 is going to be 0.231. Again, that decimal here, so this is a perfectly fine answer, a reduced fraction, or the decimal rounded to the 3rd. The decimal that I got on my calculator when I divided 3 out of 13 was 0.23076, and it went on and on. So using the 7 to round the 0, my 0 would go up to that 1 right there. Let's look at the next one. Probability of red. Again, half the deck is red, half the deck is blue. So if I think about it in terms of number of cards, there's 13 hearts that are red, and there's 13 diamonds that are red, so that's a total of 26 cards. But again, you know that that's the same thing as a half. Half the deck is red, half the deck is black. A red king, not just king, red king. So a red king, there's 1, there's 2. There are 2 red kings in the deck, 2 out of 52, or in other words, 1 out of 26. So that's a perfectly fine way to answer it. If I find the decimal here, 1 out of 26, and again, as I'm typing these things into my calculator, I highly encourage you to get your calculator out so that you can practice and make sure that you're getting the decimal that I'm getting. So I get 0.038 there. And some of you may ask, you can write the 0 in front of your decimal point, or you don't have to. It doesn't really make a difference. If you, oh, hello. If you don't write the decimal, you go away. If you don't write the decimal in front, make sure that your decimal point is prominent so that we can see it and tell where it is. All right, now let's talk about complement probabilities. It says calculate the following complement probabilities. Complement probabilities are basically the probability of something not happening. Okay, so we need to think in terms of, I always find it easiest to think of it in terms of percentages. If you think of a whole, like a perfect score on a test, a perfect score on a test is 100%, right? If you got 80% of the test correct, that means that you got 20% of the test wrong, okay, right? Because 80% plus 20% gives you the 100% of the test. So when we think about complement probabilities, we're thinking about the other piece that's going to get me to that 100%. Okay, so complement probabilities, the way you find it is you take 1 minus whatever your P of A is, because you need 100% minus the successes to give you the probability of failure. That's the other way of thinking of this complement probability. It's like the probability of failure. Instead of saying the probability of success, it's the probability of failure. So you take 1 minus the successes, and that gives you the probability of failures. So let's take a look at part A. I have, when drawing a card from a standard deck, what's the probability that it is not a diamond? Not a diamond. So there's a couple of ways to think of this. Number one, you could go back to the deck of cards and you could just count the cards that aren't diamonds. That would be fine. Or you think of this as 1 minus the probability of getting a diamond. Well, if I take 1 minus probability of getting a diamond, there are 13 diamonds out of 52 cards. So 1 minus 13 out of 52. Now, in your calculator, you can just straight up put parentheses around this and type it in. 1 minus, open a parenthesis, 13 divided by 52, close your parenthesis, and you'll get a decimal. Or you can also think of this as, remember changing one whole into a fraction, like a fraction with a common denominator? Do you remember making common denominators? I guess is where I'm going. So if I wanted to make a common denominator here, this 1 would be 52 out of 52, because one whole is any number divided by itself. And if I want a common denominator, that means I'm looking at 52 for both. Then you would subtract the numerators. And 52 minus 13 is 39. So you get 39 out of 52, which is the same thing as 3/4, or in other words, 0.75. But some of these things are also just kind of logical. If there are 4 suits and you want to know how many of them are not diamonds, that means you're talking about 3 out of 4. 3 suits out of 4 is 0.75, or in other words, 3 suits out of 4. So sometimes you can really just think pretty logically about these and come to the answer pretty quickly. So let's look at part B. When picking a Harry Potter book to read, what's the probability that you do not pick the first book? Not picking the first book. So how many books are considered the first book? The first book there is just 1. There's only 1 book that is the first book. The other thing that would be good to know is the total. If you don't remember, or if you never read Harry Potter, there are 7 books total. So there's 7 Harry Potter books. One of them is the first book. I should erase this little piece right here. Where's my eraser? There it is. Not the knot. The first book is just 1. Okay, so the first book, there is one of them. So if I want to find the probability of not the first book, I'm looking at 1 minus the probability of the first book, which in other words is 1 minus 1 out of 7, or in other words, 6 out of 7. If there's 1 success out of 7 total, that means there are 6 failures. 6 divided by 7 gives me 0.857 as a decimal. Okay, or you could have just left it at 6/7 and that would be fine. Okay, when rolling a die, what's the probability that it is not 6? Not 6. Well, 6s, there's only 1 of them. So the probability of not 6 means 1 minus the probability of getting a 6, or in other words, 1 minus 1 out of 6. because there are 6 total options on a number cube, only one of them is a 6. So then, again, think logically. If there's 6 options and one of them is a success, that means 5 of them are failures. So 5 out of 6, or in terms of a decimal, I would have 0.833 repeating, 0.833. Okay, do we have one more here? Yep. When making a doctor's appointment, what's the probability that it is not a weekday? So not a weekday. The good thing to know is how many weekdays are there? Weekdays are the days considered that we go to work or school. So Monday, Tuesday, Wednesday, Thursday, Friday, that means there are 5 of them. Total days in a week, my N is 7, okay? Because there's 7 days in a week. So then my probability of not a weekday is 1 minus the probability of a weekday. So in other words, that would be 1 minus 5 out of 7, or in other words, you could think of this as 7 out of 7 minus 5 out of 7, which is 2 out of 7. There are 2 days in a week that are not considered weekdays. Those are the weekends, if you will. I get a decimal here of 0.28571 dot dot dot, keeps going. My 4th place to round to my 3rd tells it to go up, so 0.286 there. 286, or in other words, 2/7 would be fine as well. All right, so that's the end of our basic probability. One thing that I do want you to take note of, there are some charts in Schoology that you can download. There's the cards probability chart. These 3, what I did is these 3 are separate, but I also took these 3 and morphed them into one. So if you look for just this one probability chart, that has all of these things on it. It has the red dice and green dice chart, which we'll use when we start talking about rolling 2 dice. It has the quarter, nickel, and penny chart, which we'll use when we start flipping 3 coins. And it has the standard deck of cards that we've already looked at a little bit today. So this card's probability chart is going to have all 3 of these pieces, or you can see these things separate as well if you'd like. Anyway, those are available in Schoology to you. You can feel free to print them off, or you can just look at them on your iPad, whatever you'd like, and yeah, use them at your leisure. All right, thanks for tuning in, and I will see you next time.